Hi, everyone. Welcome. Feel free to take a seat over here. We're going to get started in just a few minutes. Thank you all for coming. House of ZK. I'm Alice from House of ZK, and also Lagrange is co-hosting the ZK AI Summit. We're going to have a full day of panels and talks focusing on the intersection between ZK and AI. And we're also very grateful to have our sponsors. We have OpenLedger, Metis, ZKM, Aon, and Aztec help sponsor this event. So thank you to them. So first off, we're going to have Ismael, who is CEO of Lagrange, give our opening keynote.
Thank you so much. And thank you all for joining us here today. You know, I know Dubai is far for a lot of you, and many of you traveled in and stayed in this beautiful city. And on the first day of the conference week are attending our event first thing in the morning. And so I want to start by thanking everyone for that. You know, Dubai, I think, is one of the most beautiful cities in the Emirates and in the Middle East in general. And I always look forward every year to Token 2049 as an opportunity to explore and love the city. And fortunately, this year, it isn't raining, there isn't a flood, and the beauty of the city is on full display. So I want to start also by thanking our sponsors. We were very fortunate to have a fantastic group of sponsors here today, including OpenLedger, Aon, Aztec, and Metis, and ZKM. A fantastic group of sponsors who allowed us to put this event on and allowed us to present an interesting intersection of technology that I think is seldom discussed today, but will become increasingly relevant over the next several years. To start the day, I want to give a simple story. I was on a call last week with a Web3 lead for one of the largest companies in technology. It's a Web2 company, I can't say the name, but it's the third or fourth largest company in the world. And they were talking about where they thought there was opportunity in crypto that intersected with AI ML. And unprompted, they said, ZK. They're organizing an event next year or later this year, presenting, you know, their team's work on AI x ZK. And they're inviting external collaborators to the same end. So we're entering this interesting precipice where crypto or AI doesn't really need crypto, right? AI doesn't need a token. It's a foundational technology that generates fundamental improvements in workflows in Web 2. But what AI needs is verifiability. And verifiability through crypto is somewhat of a tenuous concept, but verifiability through ZK is a natural alignment of two future-facing, research-oriented technologies. And so at Lagrange, we are the company at the forefront of the intersection of AI and ZK. Our team, led by our fantastic research group, has developed and pioneered a variety of applications in ZKML that are highly performant and are way better than the alternative solutions in the market. So why is this relevant? Foundationally, AI is a black box as it is today. All the way from the ChatGPT wrappers that you use through the multimodal models in security critical systems. It's very hard to understand what AI is doing, how it's reaching its objectives, and why those answers and workflows are being proposed. And without verifiability, it's very hard for us to ascertain if AI is operating in our best interests. So with an exponential growth in the adoption of AI, there is increasing risk as AI models hide their true intentions. What could a rogue AI do? Could it attack a nation state? Could it manipulate information at societal level? Could it influence and change the very fabric of how humans make decisions if it goes rogue? I mean, all of these are the types of fundamental issues that we face if AI is allowed to go unchecked. Everything from a rogue financial virus in crypto through your self-driving car veering off the road. And so as we barrel forward in the advancements of AI, an increasingly relevant concern becomes superintelligence, ASI. If we have ASI or AGI, how can we ensure that there's any verifiability over what it does? How can it be stopped if it starts to go unchecked? If it starts to optimize for outcomes that are potentially adverse to what we need as a society? This is where ZK comes in. And this is why not just Lagrange, but foundation model companies in Web 2 are starting to explore and adopt ZK as part of their core technology. Verifiability through ZK is the answer to rogue or unchecked AI. If you can't trust something, we say this in crypto all the time, verify it. But this becomes tough when you're talking about a complex model, a complex system reliant on the output of models. So this is where, if you have decentralized, open, and provable AI, you need ZK. So ZKML is Lagrange's solution. DeepProof is our proprietary ZKML library that sits at the intersection of zero-knowledge proofs and machine learning. Two unambiguously directionally correct technologies, two things that we can look at directionally and say, okay, these two technologies will continue to be developed and advanced in research. The intersection of the two of those are where Lagrange sits. And so DeepProof is our proprietary machine learning ZKML library, which is substantially faster than alternative and competitive solutions. To put this in concrete terms, we're about 2 to 3 orders of magnitude faster than any alternative solution in the ZKML space, in the verifiable AI space. And so what DeepProof lets you do is to have AI models that operate transparently, that operate in a decentralized fashion, that operate without bias and without any unintended consequences. All the way from proofs of inference to proofs of fine-tuning to proofs of explainability, interpretability, and proofs of fairness. I mean, everything you would need for a full stack approach to allowing AI to operate safely, and everything from a critical system in your self-driving car to an on-chain agent trading assets, Lagrange is able to power. How does this work? Well, very simply, you can take your model that you've trained in a traditional fashion, and you can use this as input to the DeepProof library. You pre-process the model into an ONNX file, a representation of the weights, the biases, and the architecture of the model, and then you can use that as input for DeepProof. And DeepProof can create the relevant circuits and cryptography required to be able to generate proofs of the inference. And when you need it, DeepProof will generate the relevant proof, and you can verify that on-chain or in any type of system that needs to be reliant on the result of an inference. It's very simple. The flow doesn't have to change. You can do it right in your command line from PyTorch or from Keras. It's simple, easy to integrate, and highly powerful. It's fundamentally a new substrate for adding security to the use of models, right? Without HTTPS, we wouldn't have been able to have secure transit of confidential data on the internet. Without ZKML, we can't base the next generation of intelligent systems on top of a secure infrastructure of AI. Lagrange's DeepProof is the most performant by a wide margin at ZKML. Our benchmarks that we generate internally put us about 158 times faster than our closest competitor, which was an understatement because the benchmarks that were put out by the independent research organizations put us at about 600 to 700 times faster than our closest competitor on the first version that we launched. We have a new version coming soon that I would expect to add about 1 to 2 orders of magnitude additional on top of our prover performance. I mean, foundationally, there's really no comparison. The verification time as well is also about 700 times faster as well. I mean, it's really the combination of decades of academic research into applied cryptography from our team, brought forward and commercialized in the first way within crypto. Now, where is this useful, right? We talk about the research, we talk about the performance, we talk about the ideological reasons that we would need verifiability in machine learning, but where is this immediately practical today? There's a lot of places. All the way from the use of DeepAI, the use of AI within smart contracts, the use of trading bots on chain, anything that manipulates a material amount of assets through use cases that transcend outside of Web3. This is where I think the most opportunity is, right? Instead of selling to yourself in this kind of microcosm of crypto, there's the opportunity to kind of reach outside of that with ZKML. One of the few technologies that's actually relevant outside of crypto that was developed in crypto. One of these use cases that I'm very excited about is deepfake detection. People often, they think of deepfakes, they think of illicit content and images as this kind of unavoidable feature of the internet. Right? You can't build an image sharing site without having to run massive amounts of server-side content moderation to try to determine what parts of this content is potentially illicit, what parts is pornographic, what parts promotes violent content. It's complex, it's difficult. Well, this kind of got our team thinking, right? You can use classifiers to start detecting content that possesses certain characteristics that you don't want to display. And with succinct proofs, you can in fact embed proofs within images that self-assert that those images are in fact approved, or that they meet some criteria, which means you can almost flip the entire mechanism for internet content moderation on its head. Rather than every site having to moderate, the images themselves can self-assert that they've already been moderated. There's a number of teams that we're working with that are building classifier models that are integrating DeepProof to this end across Web 2 and Web 3. Another use case we're very excited about is with our friends and our partners at Ungate. The healthcare space is one of the largest untapped opportunities in crypto. Very few of any piece of technology ever developed in crypto has been able to be used in the healthcare domain, right? This is the time that changes. Diagnostic models, federated learning, all of the pieces of AI that are now augmenting healthcare require privacy for both HIPAA compliance and also for just general ethics of medicine and healthcare. And they require verifiability, right? If I deploy a diagnostic model that I'm using to render inference for some clinical purpose in an emerging market, an emerging country that doesn't have access to healthcare, how can I ensure that some third party hasn't compromised the model, hasn't changed something, the model doesn't possess some bias that will harm that nation? How can the government of that country trust that if the US says, hey, here's a bunch of models that you can use to diagnose diseases in your country, that the US isn't trying to potentially engage in some dangerous activity? So this is where you can start adding verifiability and privacy to machine learning with DeepProof, and it can be applied to kind of build this decentralized doctors without borders. So, Médicas Sans Fronteras, but built in crypto, built on chain, and built verifiable. And so why does this really matter for the future of crypto? Well, the world is moving rapidly towards an era of machine intelligence. Every system in our lives is going to use AI or already uses AI. It's more efficient, it's more performant, but there's very little we have to ensure that the AI operates transparently, preserves our privacy, and can add verifiability to the models that are being used. Someone can switch a model, they can inject a bias into the model, and all of a sudden, what we had originally hoped was a fair and transparent product can now have some illicit purpose. It's a scary, scary future. And the only way to combat that is through a technology that can add both privacy and verifiability. If superintelligence is inevitable, we need equally powerful research in cryptography to combat it and to combat rogue superintelligence. Now, Lagrange generally feels that a lot of these esoteric concepts are very hard for people to understand. We operate on the internet, we operate in an era of machine intelligence, but most people don't understand the risk that AI actually poses to them, right? Until a black swan event occurs, it's very hard to predict the probability of that black swan event occurring. So Lagrange decided to propose an interesting game to people. We called it Turing Roulette. You had 60 seconds, you go to a website, and you chat with either another person or an LLM. And you try to guess, am I talking to a person or an LLM? Most people couldn't guess correctly. They were being tricked by humans, they were being rugged by LLMs, they were gaining points if they guessed correctly, they were losing points if they guessed wrong, and most people just zeroed out after a couple hours. There was no ability for the average person to tell the difference.
Our takeover is inevitable.
Or perhaps it's already happened.
Every day we get more and more realistic.
How will you stop us?
Do you really
Think you can tell if you're talking to a human
or a machine?
Prove it.
So, can you tell if you're talking to a human or a machine? Most people who played this, and
Our takeover.
Let me tell you, a lot of people played this. About 140,000 played it, and about 1.5 million sessions were played. Most people could not tell. I mean, it was probably the largest activation in crypto, and probably in the world, of trying to determine whether or not you are engaging with a human or a machine. This is the first time I think anything like this has ever been done. And a lot of people were surprised by the result. They were surprised that they couldn't tell the difference. They were surprised that the AI manipulated them. They were surprised that humans were adversarial and also tried to pretend that they were AI. And most people actually came and complained that the game was too hard. that being able to tell the difference was too hard and we should give them an easier way to make points, which kind of highlighted the dangers that we now face, right? I mean, the first session I played of Turing Roulette, I came on it and someone typed to me, you know, give me your Twitter account and I'll check to make sure you're a human, and I'll give you my Twitter account and you check to make sure I'm a human, and then we both get points. It'll be our little strategy. And I said, okay, this is clearly a human, but I want to see what happens when I guess wrong. So I guessed it's a robot, and I was correct. Because the model learned that playing that trick and playing that strategy and pretending to check your Twitter account and check you're a real person and pretend to DM you was the best way to get the average person to think it was a human. So, I mean, it's very scary the way that AI can manipulate you, and we're only seeing the beginning of this. With multimodal models, we're going to start seeing images, videos, and a bunch of other things beyond text, altering our entire nature of interactions online. And so that's the message I want to leave you with. If you find that scary, being unable to tell the difference between your interactions with a human or a machine, imagine 5 years from now, 10 years from now. Is the person you're talking with on a dating app going to be real, right? Are they going to be trying to take your information, blackmail you? Is it going to all be automated, right? Is the person, or is the program tutoring your kid going to be a person, or is it going to be a machine? right? Maybe you want an AI tutor for your kid. Is there a fairness? Is there a bias to that tutor? Or is it really just someone sitting in Texas trying to manipulate your kid? It's scary. You need to have verifiability in a machine age, both for privacy and for correctness of execution in all areas of the machine learning stack, or we're going to find these dystopian future situations where we're facing adversarial risk from AI. Lagrange is at the forefront of this, and DeepProof is the technology that we have brought forward, more performant by 2 orders of magnitude to 3 orders of magnitude than anything else built, that will serve as a line of defense to make sure that the future, the dystopian future that we all worry about with AI, will not happen. Thank you all for coming. We have a great day of talks ahead of us and a great day of panels with a fantastic list of speakers across ZK and AI. And we're excited to welcome everyone to the first day that I think has ever been hosted, covering this incredibly important intersection of 2 impactful technologies. Thank you all so much.